Okay, CS fundamentals in Python. We're moving on to talk about another data structure called lists. And lists are a little bit different because they're actually a collection of other pieces of data typically. And they're really common in a lot of different programming languages. They're not all called lists. Often they're called arrays, is what they're referred to. But in Python, they are called lists. And I'll tell you a little bit about them. So, lists are a data structure that is a collection of other objects or elements, depending on what you want to call them. For example, you might have a list of integers, right? You might have a whole list of individual integer types. You might have a list of strings. You might have a list of booleans. You might have a list of floats. You can have a list of any type. In fact, in Python, you can have a list of mixed types. Now, that's not true for every programming language, but it is something that's convenient about Python. It also can lead to errors, so it's something to be careful of. Other languages don't permit that, specifically so that when you're doing work with a list, you know that every element in that list is of the same type. Python does not protect against not having the same type in every element of the list, so it's something that we have to be aware of as we program. Elements within a list are indexed just like they are with a string. So if you want the first element in a list, you would go to index 0. If you want the second element, you'd go to index 1, and so on and so forth, not unlike we were doing with our lists when we wanted individual letters or characters. And it's important to note that lists can also contain lists. So you can have lists of lists of lists of lists. In other languages, we would often refer to them as multi-dimensional arrays, right? When you have an array inside, arrays inside of an array, that's like a two-dimensional array. But in Python, again, we're going to refer to them as lists. So let's actually practice with some of our lists and let's do some of our programming. So let's start off by just making a simple list of integers. We do it by putting things in a bracket system like this, separated by commas. So this is a list of integers. And if we wanted to access parts of this list, let's say, for instance, we wanted to print out the first element, we would do nums, and then we would do square brackets, and then we would go to the 0th element. Let's go ahead and run this. Now, notice again that I am in my virtual environment here, and my virtual environment is activated. So I'm going to say Python 3 lists.py and run that, and I get a 5 because I've asked it to print out the first element in the list, and in that case, it is the number 5. I could also print out the second element in the list, and that is 10. I can print out the list itself if I wanted to. And then it would print out all of the elements surrounded by the square bracket. Yeah, so that's what a list looks like, essentially. If I wanted to do any changing to the list, I would access the index of the thing I wanted to change, make the change, and then it would be different, right? So if I say nums 0 equals 17, and I go ahead and print out nums again, let's see if we notice a change. And here you'll notice the first time it prints out 5, 10, 4, 2, 34, 27. The second time the 5 is replaced with a 17 because we've used our assignment operator to assign a new integer to the first position in our list. So that's how you can edit a list as you're going along. You can also, as I said, declare a list of mixed types. So if we were to say, if we were just to call this generically some list, and then go through, and maybe we have a 5, maybe we have a true, maybe we have a 4 as a string, maybe we have a 2.7, which would be a float. This is now an array of different types. We still need our square bracket. And let's go ahead and print out, or a list, sorry. I am going to make that mistake 100 times, I bet, because it is so common in other languages to refer to it as an array. But as I've said, in Python, we call it a list. So let's go ahead and print we can change what the first part of our list is. I also think this will be interesting. So I'm going to go ahead and run another loop. We haven't talked exclusively about loops yet, but I'll program it and you can follow along. And then I want to print out the type of each element as we go through it, just to see kind of what it says. So we're going to say for element in some list, we're going to print the type of element and see what that gives us. So let's go ahead and you'll notice it says 5 true for 2.7, and then look at the types, right? Class integer is the first one, great. Class bool is the second one. Class string is the third one, and class float is the fourth one, as we would have guessed. So you can see there it's actually mixed types, right? We can see that it's not one generic type that happens to be able to hold all these values. For instance, if we had done, let me show you a change. What if I had done this? Am I still producing a mixed type list or not? Well, let's run and see. Let's run this code and find out. Okay, interestingly enough, because of the change I made here, it changes the first one to a integer, but let's go ahead and change that back for a second. And now we have class string, class string, class string, class string, class string, because I've put quotes around all the values. So the whole thing has class strings. I would be interested, I'm actually not sure of the answer to this, but let's go ahead and print type of some lists and see what it gives us. Class list. Okay, so it does have that its own class, and it's called a list. Great. So class list, and then each one of the elements in there is a string. Oftentimes, what you'll have in a lot of other languages is instead of like an array being its own type, it would be specifically an array of something that would be the type, right? Like an array of strings, an array of integers. In this case, list is its own type, and it can contain all different types within it. Let's see what it would look like if we had a list of lists. So let's imagine for a second we were having some sort of, we're making a program to make lunch tables, okay? So we would have a list, theoretically, right, called tables. And inside of tables, we would want to assign it a bunch of different tables. So table 1 would be like Jimmy, Joe, and Frankie, let's say, right? And then maybe we have table 2 that has Sandy, Jen, and Kevin at it, right? You could have all sorts of different tables, and then we can actually assign that each table as a element in another list. So we would have table 1, we would have table 2, and now we have this two-dimensional lists. And let's see what information it'll tell us about our two-dimensional lists. I'm going to get rid of those two things. Let's just see what it says. So our two lists are Jimmy, Joe, Frankie, Sandy, Jen, Kevin, and they are of class. The two-dimensional list is still of class list. It's just a list of lists. But let's say we wanted one particular element out of our lists of lists, right? So we're going to print the second person. Let's make this an F string. The second person at the second table. And I should be able to spell things properly. Okay, good. And let's go ahead. And the way we would do this is we would say, okay, tables, we want a few different things. We want the second array. That's what tables 1 would do. But then we can index further to get inside that array and get the second element of the second array or list, We run that, and we see that the second person at the second table is Jen. And that's correct. If we look up here, go down to table 2, the second person is Jen. So when you're indexing inside a list of lists, you sort of do a double index. You index to the list you want, and then you index to the part of the list that you want. And you can do that with square brackets at the end. One other thing I want to talk about is what if we want to copy a list? There's a couple of different ways we could do it. So let's say we wanted to copy table 1 to another list. Let's say we were going to do table 3 for some reason, and we sort of wanted it to be a copy of table 1. We could say, let it equal table 2, and we'll just do this. And what that's doing is that's indexing through each element and then copying it over. And I want to show you, this is actually sort of a tricky thing with programming languages. So now, let's do table 3. Let's take the second element, and let's change it to Sarah. Okay? I want to print out 2 things. I'm going to get rid of this for a second. I'm not actually interested in tables right now. I just want to deal with table 3 and 2 for a second. Let's now print out what table 2 looks like and print out what table 3 looks like. Now, I want you to make a prediction. I've set table 3 equal to table 2, and I've changed an element on table 3. When I print out table 3 and table 2, what should print out? Am I going to see Sandy, Jen, Kevin, Sandy, Sarah, Kevin? Or am I going to see Sandy, Sarah, Kevin, Sandy, Sarah, Kevin? Is it going to change? Is the change to table 3 going to affect table 2? Make your predictions. And let's print out. And in this case, it did not change. It was table 3 changed fine, table 2 changed fine. I want to make a change to our code for a second. I'm going to say that table 3 is equal to table 2, and I'm going to take away that bracket, colon, bracket. I want to see if it makes any difference. Both now say Sandy, Sarah, Kevin. I didn't, in the code, change table 2 directly. I just changed table 3, but the change to table 3 affected table 2. Why? And here's the answer. It's the difference of copying by value and copying by reference. I'm going to slow down a little bit and talk through this so it's really clear, because this is very confusing. Right now, in code, we are saying that table 3, the variable table 3, points as a reference to the memory location of table 2. So when I do this assignment operator, I'm not assigning the values of table 2 to a new list, table 3. I'm actually assigning a reference to the memory location of table 2 to table 3. Thus, any changes I make to table 3 are pushed along the pointer, the memory reference, to table 2. And then they're made in table 2 as well. So in memory, what I'm actually having is I have a box with the values for table 2 in it, and then I have another box called table 3 that is really just an address. It's a memory pointer that says, oh, table 3, yeah, I'm looking at table 2 over here. So any changes you make to table 3 actually get pushed along that pointer reference to table 2. Now, if I instead, so let's call this table 3 reference, and then let's make a different variable called table 3 value copy, and that's going to be equal to table 2 with this bracket at the end. Because what the difference is instead of doing a reference copy where table 3 as a variable is just holding a pointer to the place in memory where variable 2 is, this is instead taking each value of table 2 and copying it to the memory location of table 3. So table 3 is its own thing that just happens to have the same values as table 2. And thus, if I say table 3 reference, and that's equal to Sarah, but I say table 3 value copy, and I take that first position, and I set it equal to Rob, and we print out table 2, and we print out table 3 reference, and let's go ahead and print out table 3 value copy. Stop for a moment and see if you can predict what each one of these is going to print out. Remember, originally I set table 2 to Sandy, Jen, Kevin. I made a reference copy and a value copy. On my reference copy, I changed the second value to Sarah, but on my value copy, I changed my second value to Rob. So can you predict what these are going to print out? All right, let's see if you're right. So how many of you predicted Sandy, Sarah, Kevin, Sandy, Sarah, Kevin, Sandy, Rob, Kevin? Because if you did, that's correct. Because the reference copy changes changes table 2 and just continues to point at table 2 where the change was made. The value copy copies the values over and then changes one of the values and then is only referencing the values that were copied over. So that's the difference between a reference copy and a value copy. There is another way of doing a copy. We can also use this method. So table 3, we'll just call this copy method, because there is a copy method, meaning a function associated with the class of list. So if I take table 2, and I set dot copy, I'm calling the method copy, and I am using it. Now, the question becomes, do we think copy, the method copy, produces a value or a reference? Let's find out. So if I'm going to go ahead and get rid of the changes I make to any of these. And let's just print out table 2 here. So if I now make a change to table 3 copy method, and I say the second value should equal Jan, let's say. Let's see if table 2 is changed. Table 2 is not changed. I should have picked a more different version than Jan. Let's say Sam. Okay. And I'll show you again. Still, table 2 is not changed. So the copy method is actually doing a value copy and not a reference copy. It is another way of essentially doing this here by using the dot copy method. There is also a deep copy method, but I think that is part of a different library. So we're not going to go into it because it's not part of the base language, but just good to know that table 2 dot copy, the dot method of copy, is copying as a value copy and not a reference copy. I know value and reference is complicated, and it's a little bit more object-oriented programming where we'll talk more about that, but I think it's important just to sort of know what's happening with lists, because a common mistake is to do this reference copy, make changes to it, and not realize why the original one is getting changed. It's because of that reference versus that value copying. Okay, that's it for this lesson. Next time we're going to talk about loops.